I'd like to first of all thank all my subscribers. They're a small but noble group. And I'd also like to give credit to the guy that I got a lot of the ideas for mapping ADO.NET objects into custom C# controls, which is sort of the phase of the CAX series that we're going into now. This is the information on Matt McDonald's book. I actually haven't read his book, but I got a couple programs off the internet that were excerpted from this book, and I learned a tremendous amount from them, so I highly recommend it. Most modern relational database systems, or RDBSs, are made up of two types of objects, so to speak: tables and relations. A table we've looked at a few times in various lessons, and it's basically a XY grid where you have along the horizontal column names such as movie title, year, description, and so on. And then on the vertical axis you have records, which are often numbered 0, 1, 2, 3, 4, and so on. And each of these records fills in a value for these column names. And all the modern relational databases are based on these types of tables. And within the tables there's quite often special columns that are used to link tables together. And when tables are linked together, it's referred to as a relation. And the two types of columns that are most often used are called keys. One type of key is a primary key, and that uniquely identifies a record. It's often created with auto increments so that you have a unique number for each record. And then the other type of column is called a foreign key, and that essentially has the same value as a primary key. It's usually a primary key in another table. So in the case of the two tables we're looking at in our ongoing CAX lessons, we have a movie table and we have a genre table. And the genre table has a genre ID, which is a number, 1, 2, 3, 4, and so on. And the second column name in the genre table is a meaningful name, like science fiction. So you can have genre ID 1, genre name science fiction, genre ID 2, genre name horror, and so on. And in the second table we have movies, and that has a movie ID, which is the primary key for the movies table, and which has values 1, 2, 3, 4, and so on. But it also has a genre ID, which is a foreign key, and the values in the genre ID map into the values in the genre table. So that if I have a record in the movie table that has a genre ID of 2, I can go to the genre table and look it up. In effect, I can say, oh, it has a genre ID of 2, that means it's horror. If it has a genre ID of 1, that means it's science fiction. And needless to say, this saves a lot of space, because if you have 50,000 records, all you have to do is have an integer identifying the genre, and then when you print it out you can look it up in the genre table and not have the word science fiction repeated 50,000 times. Graphically, this is what the foreign key to primary key mapping looks like. The blue column is a foreign key in table A, say genre ID and movie. And the red column in the bottom table is the primary key in the second table, say genre ID in the genre table. Basically, the values in these two fields link the two tables together, so you create a large single table often referred to as a join. In terms of the diagram in the previous lesson, this adds another dimension to the ADO objects. We still have the data set, the data table, and the data rows objects, but now we have a new object called DataRelation, which now links the two tables together. When two tables are linked together in this manner with key fields, such as primary keys and foreign keys, it's referred to as a relation, and in the SQL it's referred to as a join. In fact, the word join is quite often used in the SQL that creates the relation. But we're not using SQL in the case of this program. We're using an ADO object called a DataRelation. Program for CAX 5 is very much a continuation of the program for CAX 4. Once again, we have the using system.windows.forms and using system.data in order to access ADO.net objects. And once again, we have the data set declared at the top of the class we're creating for accessing the ADO.net objects in the private data set DS. Data set is the type and DS is the name of the object. In this case, we add a second object, which is a data relation, and we call that movie and genre. Within our constructor, we instantiate the dataset object by saying ds equals new dataset. In the previous program, we actually declared and instantiated it on the same line, but I'm demonstrating a different way of doing it. And once again, we populate the dataset with the read XML schema and read XML methods of the dataset object. And this is reading in two tables, which are the top two elements of our XML file. One table is movie and the other table is genre. And here we start defining our data relation object. Basically, if I can get it centered here, this says movies and genre, which is our data relation object, equals new data relation, and the first parameter, movie genre, is the name of the relation. The second parameter is the table that contains the genre code and the genre expanded name, which in this case acts like the parent table. And the second table contains all our movie detail records. And in both cases, we have a column called genre ID. And we're saying connect the parent table genre column genre ID to the child table movie column, which coincidentally has the same name, genre ID. It's actually very common practice to give those two the same name to show that they're linking the tables together. And then in a very important step that if you leave out it won't work, say the dataset.relations.add and then add the relationship we just created to the relations object within the dataset object. So all this code is within the constructor, which gets called every time we instantiate an object of movie class type. Then we have two functions. In the previous program we only had one. The first one gets a data table, which is almost identical to the one in the previous program, but in this case, rather than getting the movie table, we're going to get the genre table. The second function is get movies in genre, which if you look at the return type here, this is actually an array of data rows, so it's going to return more than one data row in all probability. and it also has a receiving parameter that is another data row. In this case, the data row it receives is going to be a data row from the genre table, and the data rows it returns are going to be a series of data rows from the movie table. And what actually returns these is the getChildRows method of the data row object. And the data row is a genre row, so that's actually giving it a genre number within the object that's being passed. And then it's also, this function has a parameter of movies in genre, which gives the relationship that defines what the child rows are, i.e. the genre ID is the same in both tables. So if we pass it a genre object that has a genre ID of 1, it's going to return all the movie rows that also have a genre ID of 1. In other words, that's what the definition of a child row is, because of the way we define that data relation. Now if we look at our form class, the first thing we do is define a object of movie class, the class we created to handle ADO.NET objects. And when we instantiate this class, it calls the constructor, which establishes the relationship and reads in the XML file and so on. Within the form load method of the form class, which happens right at the beginning when the form first loads, we have two for each loops nested inside each other. The outer for each loop says get a data row from the or get all the data rows from the getGenre rows, which the getGenre, remember, returns the data table of genre. So this will bring in the 3 rows in genre, which are the science fiction, horror, and fantasy rows. And then print out to the screen what the first name is, the second name, and so on. Then within the second nested loop, we use our method that reads in the child rows based on what the current parent row is. So if the parent row is, first parent row is science fiction, this will get all the rows in the movie table that are related to this science fiction and return those one at a time in the for each loop. And as each one's returned, print out a dash to show it's a child, and then print out the movie title from that record. So if we compile and run this, we get the following output. First, the science fiction prints out from the genre table in the outer loop. Then the inner loop calls our routine to read in all the children, and it prints out each child in turn. 2001: A Space Odyssey, Brainstorm, and Black Hole, the 3 science fiction. Then we fall out of the inner loop into the outer loop again and print out the horror from the genre table, the next genre, and we print out the 2 children of horror, Alien and Boys from Brazil, in the inner loop. Then we fall out of the inner loop to the outer loop again and print out fantasy in the outer loop, the 3rd genre, and we print out Lord of the Rings and Harry Potter, the 2 children of fantasy. Well, starting with the next lesson, we're going to look at customized controls that present this kind of information, and it's a tree information, in a way that's a lot cooler and a lot more usable. And it's in fact the custom controls that the Explorer, Windows Explorer, and the mail programs like Outlook Express are based on, namely the tree view, the list view, and the split container controls. So I'll see you next lesson. I hope you learned a lot, and remember until then to focus and learn a lot everywhere.